Okay, so this is my kinematics reassessment. A skier with a mass of 63 kilograms starts from rest and skis down an icy, frictionless slope that has a length of 50 meters at an angle of 32 degrees with respect to the horizontal. At the bottom of the slope, the path levels out and becomes horizontal. The snow becomes less icy and the skier begins to slow down, coming to rest in a distance of 140 meters along the horizontal path. What is the speed of the skier at the bottom of the slope? What is the coefficient of kinetic friction between the skier and the horizontal surface? So for the first part of the problem, I know that when the skier makes an angle of 32 degrees with respect to the horizontal, the acceleration of the skier along the icy slope will be acceleration in the x direction equals gravity sine theta. So I plugged in what I knew. I knew gravity sine theta is 32 degrees, and that gave me 5.2 meters per second squared. And then the total distance traveled is change in x equals 50 meters, and the initial velocity of the skier is the initial velocity x equals 0 meters per second, and the final velocity of the skier at the bottom of the slope is going to be final velocity x. So this is my kinematic equation, and what I did was plugged in what I knew at first, and obviously this 0 is going to be gone along with the square, and then this side of the equation gave me 520 meters squared seconds squared. So I took the square root of that number, and it gave me 22.8 meters per second, and I rounded to 23 meters per second for the final velocity in the x direction. So let me see something. So when I took the square root, I didn't take the square off. So now we know the initial velocity of the skier at the bottom of the slope is 22.8 meters per second. The final velocity of the skier after traveling a distance of 140 meters is 0 meters per second. And we're going to represent that by velocity final 2x. So I got this magnitude of acceleration formula for the skier on the horizontal surface would be the second final velocity minus the initial final velocity divided by 2 change in x. So I plugged in 0 for my second final velocity because he came to a stop, and then I took the 22.8 from the first final velocity that I found on the previous page, and I put it over here. Well, I squared those and subtracted them on top, divided by 2 times 140 meters, and that gave me 1.86 meters per second squared for the magnitude of acceleration. So then I have this coefficient of kinetic friction formula, and I put the acceleration of the skier that I just found on top divided by the normal force or gravity, and that gave me 1.86 meters per second squared divided by 9.8 meters per second squared, and that is 0.18979, and I rounded it to 0.19. But I think in this formula this is going to be actually gravity. Yeah, because the normal force would be with the mass of the skier, I believe. So that's my kinematics reassessment.